Hello everyone, myself Monu from group number 322. Today our topic is nonlinear dynamics of membrane. As we have seen, the nonlinear property of excitable membrane are distinctly manifested in the generation and propagation of a nervous impulse. Let us consider periodic change in the state of membrane is stabilized in the number of experiment. For instance, there were observed oscillation of electric potential in very thin polyelectrolyte bilayer membrane. The bilayer consists of a polyacid and a polybase. Thus, it has three zones: a negative charge zone, a neutral zone, and a positively charged zone B. The membrane was placed in a 0.15 m solution of NaCl. When a negative potential was applied, periodic impulses were observed on the side of polybase and at a certain when a negative potential was applied, periodic impulses were observed on the side of the polybase and at a certain critical value of current here were observed undamped oscillation which persisted for hours. The current through the membrane consists of movement of cation through the membrane of cation through the zone A and of anion through the zone B. As a result, NaCl is accumulated in the central neutral zone. The increase of the osmotic pressure lead to the appearance of a flux of solvent into the membrane and an increase in the polystatic pressure in it. At the same time, the increase of the salt concentration causes the polyelectrolyte molecule to compress, which also increases the pressure. When this increase exceeds the osmotic pressure, the solvent flux change in the sign and the salt contraction inside the membrane increase even more. A concentration gradient arises. The salt leaves the membrane and flow out after the membrane attains a maximum concentration. This is followed by relaxation. The membrane return to the initial state and the process start again. The Tural membrane oscillator consists of two cells filled with an electrolyte of different concentration and separated by a porous glass membrane containing bound negative charge. When a direct current is passed, a potential difference is created on the two sides of the membrane and shift in liquid level occur in the cell. At high constant current, periodic oscillation in the liquid level and a membrane potential occur in system. Because of the presence of negative charge in the membrane, the electrolyte in its spore carry many cations. The external field can use the movement of cation and the solvent. Uh, the concentration distribution in the membrane pore depend on the amount of the flowing liquid and the flow rate. In turn, these factors governs govern the resistance of the membrane. The force that act on the system depend on the state of the system. There arise auto oscillation, the theory of which has been developed by Turles, Merkin and others. In biological membrane containing enzyme which has cooperative property, the periodic change in the state of membrane may be determined the non-linear coupling between transport of matter and change reaction. We shall consider a simple example. Suppose that the enzyme catalyzes the irreversible degradation of substrate as the chemical flux is given by where S is substrate concentration is that of enzyme, K is the rate constant. Suppose that there is a critical substrate concentration SCR at which the enzyme undergoes cooperative conformational change that lead to an increase in its activity. The rate constant K increase from K1 to K2. The dependence Jm is present on in figure 16.14. Because of the cooperative J can undergo a transition similar to a phase transition. The substrate enters the system by which of diffuse through the membrane at rate where S node is the concentration, S is in the source which is particularly constant at J cam is equal to J. Define the rate of change of concentration is this system is a steady state. Our next topic is Autowave process in the cardiac muscles. As we have seen, the muscle tissue is an excitable medium and excitation imposed by a network of nerve fibers induce mechanical chemical process. The process taking place in excitable media are therefore of greatest importance for physical, in particular for the physiological of the cardiac muscles. The concentration of excitable medium in as a medium in which the propagation of nervous impulse occur without damage at the expense of the energy stored in cell was introduced by Wiener and Robert Bluth. An impulse is generated by each point of the medium. An example of one-dimensional excitable medium is a nerve fiber. Each point of the excitable medium may be in one of three states: rest, excitation, and refractory state. If a stimulation is applied to a small portion of the fiber in the rest state, it will become excited. The excited state persisting during the time and then pass over a refractory state of duration. In the refractory period, the fiber section no longer responds to the excitation signal, and hence none of the fiber portion can be excited with a frequency higher than in excitable media. There are realized auto-oscillatory process described in section 16.2. Wave source may also arise in such media in which none of the element is capable of being excited spontaneously. In not auto oscillation, the formation of such source is associated with the special portion of the medium and excitation wave. In considering the Brolossow Jabotinsky reaction, we encountered two type of wave source leading center which generate concentration wave and reverse reverberator's rotating spiral wave. The formation and subsequent multiplication of reverberator play a very important role in the mechanism of fibrillation, a very dangerous cardiac arrhythmia is disturbance of the synchronized of wave propagation in the cardiac muscles. Instead of in chronic concentrations, there arise irregular, disordered fluttering, and the organism is rapidly destroyed or if no defibrillation is medium. Spiral wave in a homogeneous two-dimensional system appear in the presence of an opening whose parameter exceed the wavelength. Uh, the circulation of the excitation wave reverberator is also possible in a continuous medium with non-uniform refractory period. If an impulse is sent to a certain ring-shaped region of the medium, it will not circulate it since the excitation wave propagation in a clockwise and its counterclockwise direction will meet and cancel each other. But if the refractory period is not the same everywhere, a circulation will arise due to transformation of the rhythm. Figure 16.16 show an inhomogeneous medium consists of two regions with different refractory period. The interval T delta between two source wave alpha 1 and alpha 2 is such that the wave alpha 2 cannot exceed the region with this. In such a case of inferent alpha 2 is disrupted, the refractory tail has a larger length in region 2 alpha. The transformation of rhythm consists in cancellation of second impulse. Thank you.